A very good morning to all of you guys once again. As you all know, my name is Chahil, and today we are going to solve one more LeetCode problem. And the problem that we are going to solve today, it's not gonna be related to linked list. It's gonna be related to the string. So let's move on to the LeetCode and try solving it. Okay, so as you can see, guys, that the problem statement number is 151 and its title is reverse words and a string. So we will look about how to solve it and reverse the words within a particular string. So here it's a medial level question, and talking about the description, we are given an input string S, and we have to basically reverse the order of the words. And a word is something that is consisted of a non-space characters, and a word is separated by at least one space. So here it's written that note that S may contain leading or trailing spaces or multiple spaces between the two words. So it means that there might be a space at the ahead or also at the bottom after a word, and it might be multiple or more than that. So we also have to look after that edge case before reversing it, and we will also look after it. And the return string should not have a single space separating the words. Do not include any extra spaces. So as you guys can see that the problem has told us to not include any extra space. So it means that we will not have to include extra space. And talking about the basic optimal basic brute force approach, we can easily use the stack. But as you know that using stack, it will result in using extra spaces as well, because in stack it's very easy, because you just push the element, and wherever you see a white space or any empty space, you just remove it, and you only get the sequence of words that you want, because it's last in first served data structure. So we will use another approach, and it will be a two-pointer approach, and it will be optimal. And using that approach, there won't be any extra space used in our code. So let's just have a brief look at the examples. So input S is the sky is the blue, and output is blue is sky the. So basically what we have to do is that we have to include a whole of a word, and when there is a space, we have to give a space, and we have to print another word starting from the backwards. It's just same as reverse a string, but here in this problem we are told to reverse the words in a string. And this is a very main example. It is hello world, but here you can see that there is a space after world, and there is a space before hello. So this is what I told you about. These are the leading and trailing spaces that are unnecessary, so look after that also. So in this problem statement, what we are going to do is that we'll use a two pointer approach. So basically we will start it from the last. It's obvious that we have to print our string from the last. We have to do it in reverse manner. So we'll use one pointer at the end. And as you can see that in worst case possible, there might be a trailing spaces after the word. So what we'll do is that we'll put a condition that if there is a trailing space, then we will minus that pointer, and where the word comes, we will use another pointer there. And what we'll do is that for that pointer, we will put a condition that unless and until there is not another trailing space, we move that pointer. So as you can see that in hello world, first pointer will be at D, and second pointer will also be at D. So the first pointer will be at D, but the second pointer, it will come here, because here is the very next space. So once it comes here, it will go there, and what we'll do is that we will print this whole world. And what we'll do is that we will the first pointer, we will also update its value. So what we'll do is that we'll basically string result. So string result, it's basically a string where we'll store our value, and we have to start from the very end. So, and we are obviously using zero based indexing, so we will just store the size in any variable. Let's just say int end, because the end is at the last, equal to s dot size minus 1, because we are using zero based indexing. So what we'll do is that we will use a while loop, and in that condition we will do that while end is greater than equal to 0. Okay, so this is a while loop we started, and what we'll do is that we will check if there is any trailing spaces. So again we will write the same condition while end greater than equal to 0, and as we all know that the string is s, so s of end equal to, so here we'll give a space. So if this is the condition, then what we will do is that we'll basically move the end pointer to the minus minus, and once we are done that, we will use another pointer at the end. So let's just say that the pointer name will be word start. So int word start equal to end, and what we will do is that if our end pointer is less than 0, then it's obvious that we will break it. So after using this word start equal to end, what we will do is that while word start is greater than equal to 0, and here we were supposed to write greater than equal to 0, instead we wrote less than equal to. So, and what we'll do is that in this pointer we will iterate unless and until there is no any space. So s of word start is not equal to space. So until that condition, this word start, we will decrement it. And after this, what we will do is that we have to store our answer in this result, in the string named result. So result plus equal to s dot substring. So the reason why we are using a substring is that we have to first print the last part of the string, and then we iterate over again and again unless and until we go to the 0. So as in s dot substring, what we will do is that we will basically write word start plus 1 comma end minus word start, because as you know that the word start, let's just say in this hello world example, word start will stop at this space. So we have to print this world. So the world will start from word start plus 1 up to end minus word start, and as you can see the end pointer is at last. So end minus word, so it will print our whole world sentence. And once we are done that, we will just give a space in our result. So it absolutely works. And what we will do is that we will also end equal to word start minus 1, because we also have to update our end pointer. And once we are done this, what we will do is that result dot pop back, because as you know that we are starting from the behind, but there will still be the leading spaces, because the loop will stop at here. So if there is any leading spaces, it will go to the end. So we will just pop back the leading spaces, and we will basically return our result. So let's just try running this code, and so as you can see that we have passed the basic 3 test cases. Okay, so we will just try submitting it, and we hope that we pass all the given test cases. Okay, so as you can see, we have passed all the 62 out of 62 test cases. And talking about the space and time complexity, it will be big O of n. And as given in the problem statement, we are doing this problem without using any extra space, and it's an optimal method by using 2 pointers. And for the better understanding, we will also move to the dry run of this code. So moving to the dry run, let's just say we start from iteration 1. And the example here is hello world, the one that we worked on. So the size will be 23. Here the I is the end pointer that we took, and j is the word start pointer, for better understanding and don't get confused. So here at first there are trailing spaces. So we'll skip that spaces. And at 21st index, there is the word D, and we will set j equal to I. And what we'll do is that we will decrement our j pointer unless and until there is another space. And what we'll do is that when we found the exact word, we will set our values of j, and we will also store it in the result, and we will also give space, and then we will basically update our I pointer as well. It will become j minus 1, and here it is 16. So you guys can see that this is how the iteration is working in this problem statement. So I hope you guys are well aware of this problem statement and how we use two pointers to solve this kind of problems, and thanks for watching.